everyone. Welcome to the last talk of the day. We have here lesson learned. Go is not JavaScript. A year in the life of Vugu, which is a Go+Wasm library by Brad Peabody. We'll have him here live for the Q&A. So let me read a little bit about him and we'll start with the video. So Brad is a software engineer with 8 years of experience as a Go developer and many more in other languages like Java, PHP, Python, JavaScript, C, C++, and probably a few more. He wrote his first line of code as a kid in BASIC on a hand-me-down Commodore 64 sometime around 1989 and never looked back. As the creator of Vugu, he spends every chance he gets trying to make the project more productive and useful and help solve the hard problems related to writing web UIs in Go. He also does some Go development consulting and is the CTO of a tech startup in the ad analytics space. He has aspirations of becoming a serial entrepreneur unless he falls in love along the way. He grew up in Southern California. He loves soundtracks by Pearl Jam and Jimmy Eat World. His hobbies include playing guitar, ukulele, and some photography. And I guess he also participated in the 2020 LA Marathon. Very cool. So about today's talk, could we make something like Vue in Go? Well, with Wasm, Go now runs in browser, and yet JS and Go code are worlds apart. So in this talk, we'll explore these differences and dive into Vugu, an experiment to make a Vue-like Go library. Examine ideas, patterns, and lessons, and anti-patterns discovered along the way. This all started as an idea that now that Go can run in the browser via WebAssembly, can we make something like Vue, but written in Go? A year later, a lot has been learned. Some ideas from the JS work out okay, but many are different. So a lot has to do with Go as a language. So let's go ahead and watch the first part of the video. Enjoy. And please, if you have questions, put them in the Q&A chat with the question mark bubble. Thanks so much.
Hello, my name is Brad, and I'm going to give a talk entitled Lesson Learned Go is Not JavaScript, a year in the life of the Vugu project. Now, the Vugu project is a Go with WebAssembly UI library and toolchain for doing that. And this talk is going to be focused particularly on what are the differences between how we do things in JavaScript versus how we do them in Go. And when building out the Vugu project, that is a big theme of, good, we're going to do something that is usually done in JavaScript these days, and we're going to do it in Go instead. So what's the difference? Cool, let's dive right in here. So just to summarize, in this talk, we'll go over briefly what Vugu is. We'll look at the tools involved, the pieces to that, that go together, and we'll talk about some important things what makes using Go fundamentally different from using JS UI frameworks. A lot of it has to do with the language itself, Go as a language. And then we'll look at specifically, we'll go into more detail on some important decisions. So code generation is one of them, right? The idea of reading things at runtime would be one way to go, or code generation would be another way to go. We'll go through that. We'll talk about templates and the decision of, that's related to the code generation subject. What do we actually write as developers when we're talking about UI markup? So there's different ways of doing that. So we'll cover that subject. We'll talk about wiring, meaning connecting together these different pieces of the user interface. We'll discuss that, and some of the techniques involved, and we'll talk a little bit about state management. I'll try to keep that one understandable because it gets really complicated, but it's a good example of something where it is a complicated thing that needs to be figured out, and let's see what we can do about it. So here we go. All right, so what is Vugu, right? It's not a very enlightening slide. But here we go. Vugu is fundamentally, it's a Go library, right? It is just, a regular library you would get off GitHub. Same thing. It doesn't introduce a whole lot of additional tooling. There is some, but it's designed to work with the regular Go compiler. So it's a Go library. There are some command line tools, and the idea is it helps you build web user interfaces that then run in the browser with WebAssembly, right? The original concept was, can we build something that's like Vue.js in Go? That was kind of how the idea started. And went back and forth. There's, like I said, some of the things we'll talk about in here are the decisions that were made and things that were tried. Okay, let's see if we can just do the same thing that Vue does. Does it work? And sometimes the answer is yes, and sometimes the answer is no. We should be doing this differently in Go. So now, okay, so here's a little example. On the left here, you have a program. This is a .vugu file. As you can see, we're looking at markup, right? We're looking at HTML tags there, and it's been augmented. If you see, there's an @click there, and yeah, there's a VG-if there toward the middle of that thing, VG-if c.showWasm. That's an example of markup, but we've added into it a condition, right? That's a Vugu specific thing. So, and then on the right, that is the development server program. It's basically a simple few lines there setting up some handlers and stuff. And those really just set it up so that we can serve web pages and we can serve the program to the browser. So those are the main pieces that you see looking at this. And we'll dive in a little deeper and explain how this works. So here we can see we've loaded an example application. And if you look at what was actually the page that was served, it's kind of hard to see, but it's just that spinner, right? And then the main WASM file is the binary executable. That's what's actually running the page. If we go and if we look at the markup that's in the browser DOM, that's been generated by WebAssembly. When you click the buttons there, the little links, it toggles stuff in WebAssembly. Okay, so aside from the tool chain that gets us our WebAssembly executable, an important thing that Vugu does is this idea of synchronizing the browser, synchronizing the output of your Go program, the Go code that corresponds to that markup that we saw. It needs to then actually make it to the browser, right? Because if in our code, when we say, good, I want to have a div tag, that's actually just a Go struct that sort of describes what a div tag is. We need to, at some point, call create element in JavaScript and actually, append child or whatever it is to go and build out the DOM. So Vugu provides that synchronization there. It actually goes and links those pieces up. So good, your original input is converted to a Go program. That is really the code generation, which we'll look more at in a moment. And we've got the synchronization, good. We've got this idea of declarative things that get attached to the DOM, the markup that you write. So if you want to say, good, I need this thing repeated several times, then you do a VG4. That VG4 corresponds to a for loop in the output Go code. Let's look at this decision to use code generation to produce the .go file, which is compiled by the Go compiler. So let's look at our options here first. JavaScript, as you know, is an interpreted language. So when we talk about it gives me a chuckle, these JS compilation, right? Well, of course, it's not necessarily compilation that's happening. The closest thing for JavaScript is we're taking JavaScript here on the left, and that is JavaScript that a person would write, and we're producing a less readable form of that JavaScript on the right. So that's really just a minification or a packing. So that's because JS as a language is interpreted. There is no other representation of JavaScript that is commonly supported other than its source code. So Go is a compiled language, of course, and it takes .go files and it has the ability to produce a WebAssembly executable. This is at the top left, we've got a .vugu file, which is what ended up being used for this as the input for markup in HTML. In the middle, we've got a generated Go code that is produced by the Vugu gen executable. You can also call it as a library function if you want to. And then our binary file, which is just a hex dump there. So that's what Vugu ended up doing for this. And let's look at why. So obviously the problem here is we're targeting WebAssembly. We need to use the Go compiler to produce our .wasm file. But how do we type markup in a way that isn't going to drive us nuts, basically? We need to be able to perform layout stuff and, meaning write HTML. And we want to be able to do that efficiently and also still use Go as a language. So there's a few different options. A couple of the obvious ones are we can either generate, we can do what we've done. This is this code generation approach. We go from Vugu to a .go file and then compile that Go file. Or another way would have been to use templates, right? So we could have done that. A Go template, the HTML/template package, that definitely could have been used. And that some prototyping was done on that. I think some other people have tried that out. And there's some interesting ideas there, but it presents various issues. The main advantage to using code generation over something like templates is it's just a more direct translation to what the Go compiler needs. If we go and use a template, then we have to read it again, and we have to read that thing at runtime. So with code generation, we end up with it's efficient because we're producing Go code, and that Go code can be compiled down to the binary directly. There's no intermediate step there. So, and things like VG-if, VG-for can have a direct translation those to an if and a for statement in the Go source code file. So this is obviously closely related to the next point, which is templates. Good, so we got a little section here on Vugu templates. Let's talk about that. So this is an example of the other way this could have been done, right? We could have said, well, let's use the HTML template package, and let's say if this thing is set, then this dot show banner there is one of the template's data. It's a property of that template data, and we could have gone and said, let's use this mechanism to edit our markup. And obviously that double curly brace syntax there is being read by the HTML template package, and that show banner variable is something that is in the client. It gets modified based on if somebody clicks on something, for example. So this is something that we can't read this just at compile time. This has to be read and executed in the browser, in memory, in the WebAssembly binary. So here's the disadvantages to this. So it's entirely sequential. So in that case, you have to read and parse the entire file to get these if statements and the includes and all that stuff. You have to run through that entire process really in every render cycle in order to make this work. You see, you have to execute. I know that the HTML template package has a parse and a execute thing, so potentially it could only be parsed once. And save some time like that. But you still really have this dynamic language issue where you're running through all of this template processing code for every render cycle. So that's definitely, there's a performance issue there. And yeah. So in addition to that, let's say we did do that. Let's say we did go through and we decided it was fast enough. We run through and we execute these templates and we produce this markup. Well, what did we just do? We just produced a text file in memory, a bunch of bytes in memory. We still have to parse that again. We have to parse the div tag and this and that, and then still go out to the browser and do, create element and set the attributes and all that stuff. So it's, even if that were fast enough, we still are introducing this other intermediate step, right? Whereas the compilation way, the code generation way, we're dealing with Go structs in memory. There's no parse step, none of that stuff. the code that gets generated is just dealing with a bunch of like, cool, a div tag is a VG element struct, and its properties are field members and stuff. So it's efficient in that regard. There's not a bunch of, we don't translate between some text format and structs in memory back and forth all the time. So yeah, we want to avoid all this runtime parsing and all this stuff. And then even if we decided that all of that was okay, and we were okay with that, and we liked the trade-offs, we would still have another problem, which is that the DOM event system doesn't have a direct translation to templates. We would still have to invent a new syntax to say things like, at click, which is equivalent to add event listener, quote unquote click, and then you add your handler function for that. So it has all these disadvantages, and it still doesn't get us all the functionality that we need. So those are the arguments against using Go templates. It's been tried and stuff like that, and I don't think it's a good solution. So code generation was the solution to that. So another point here is we could have done where you write Go code directly. You simply say these structs that represent elements and this sort of thing. You just go ahead and do that. You have a library of the various different DOM elements, and in your Go code you simply say, good, I want to go ahead and make a div tag, and this is an h1 tag, and this is the text content and all that stuff. And it does have, there are some advantages. There is a bit of a draw to that approach, and there's actually another project that's linked here on the slide, and that does that approach, and you can see the sample code and how that looks on the right. So it is a viable approach. There are upsides to doing that, right? The main downside, the main thing that I think doesn't work well about something like this is it doesn't provide a separation of when you're working on layout versus you're working on functionality that you want in Go code. Fundamentally, markup is declarative. It says there is a tag here, right? And it has these attributes to it. The closing tag has the name of the tag too, instead of a single curly brace. So if you have a big document and you've got a start up here and an end up here, it's easier to match those up in HTML than it is in this big indented tree of nested calls in Go, right? So there's that, and there's some other little things that simply make HTML better suited to the task of representing markup. Now, Go as a language is great at what it does. It is, a big difference is HTML has structure. It says what's inside what, and it gives a sequence, but there's no execution sequence to it. Go is an actual programming language where it has flow control. It has concepts of a thread of execution, a Go routine, whatever. But the point is, conceptually, there's an instruction pointer that's moving down the list here and doing these various things. That doesn't exist for HTML. They're just very different. And when you're trying to make a program and do different things, these are different tasks. They're related, and you do end up doing a fair amount of task switching between them. But really, you want the layout to be able to be done as layout, and you want the code where you're writing code and you are doing that function. If you wear that hat, so to speak, you're doing that in Go as a programming language. So yeah, that's one of the big things. Another advantage to having markup be in an HTML-like file is that you can include people in the project. People can work on that who don't have a lot of Go experience. You don't necessarily have to be an experienced Go developer to do page layout in a project where you open the files and they're HTML-like. Most of it is HTML. They can go through, they can do style changes, they can move things around, probably things that are just like VG if to say, this condition causes this thing to show or hide. That's something they can just kind of copy and paste and not have to worry about it. So it also allows a lot of productivity without even having to understand Go as a language. And I think that's important for projects as they grow larger, as you have more people with different skill sets on the team. I think that's an important part of it. So those are good. Those are the key things as to why Vugu chose to have .vugu files that are mostly markup as opposed to using Go code for all of that DOM structure. And so this slide shows that example. This is just the same example, a bit more shown here. So we've got @click that are having our event handlers there. We've got our VG-if, and we can put other things in there. So that's what we ended up doing instead. So a little more here on Vugu template files. Some of this I just covered in the earlier slide, but key ideas here are it's declarative. So instead of having our if expression and then end, which has to be processed in a full sequence, you have to scan the entire file or have that full parsing done there. Instead of doing that in a template file, the condition or the loop or any other of these types of things, they're attached declaratively to the element. So it's a VG-if attribute on that element, which then says this attribute is controlled by this condition, or VG4. This element is it's how many times its output is controlled by this expression, and it gets converted into a for loop as gone over. So good. I already covered it's HTML-like. Anybody who knows HTML can do that. So that's great. And the expressions in the file are also Go code. I think that's an important point. Interestingly enough, when I first started using Go, I've used Go templates for various things, use them for various things, sending out emails, and I've actually built some tooling to do web page rendering and stuff with it, and it's pretty cool. But it is a different syntax. It's another thing that people have to learn, and I found that even people who are Go developers and they've learned that language, now when they get to the template language, especially if they don't use it every day, it's now another language to learn, and it has its own little rules and stuff, and I understand why they're there. It's not a criticism of that. It's just that in this case, the question comes up of does it make sense to introduce this other language? And I don't think it does. I think it works perfectly well to simply say inside of a VG4 that is literally the same text that you would put in to a for loop in the Go code, and that seems to work really well. UI components are also just Go structs. So if you make a file, .vugu file, and it has, it's called top bar or whatever, it corresponds to a top bar struct. And it means that that struct lives in a package just like everything else. And when we want to say one component includes another component, that inclusion is done the same way you would reference a struct in another package. It's just a package.struct reference, right? And the markup in the file, in the .vugu file, corresponds directly to that. That's one major concept which I didn't quite, it got changed in version 0.2 or something like that of the project. Originally it was all kind of dynamic, right? It was, you would register components and then they would kind of find each other in a map and that sort of thing. And it kind of dawned on me as I was looking through this stuff that doesn't totally make sense. It would probably make a lot more sense to simply have the references be the same sort of Go reference you would see anywhere else in Go code. And so that switch was made and it's been working really well. So definitely performance is a part of this as well. If you're compiling Go code and that Go code is designed to say, good, as quickly as possible produces this DOM representation in memory, and then Vugu has another pretty optimized process for taking those structs, that graph of objects in memory, and synchronizing with the browser DOM. Those two steps are pretty highly optimized. Again, there's no parsing involved. It's just data in memory. So in terms of what we get as a WebAssembly binary, that should give us, from what I can see, the best potential for good performance. And it's worth mentioning that even though .vugu files look like .vue files, and that was originally a concept. It was like I liked that way of interacting with the system. That's sort of like presentation first. When you're working on presentation, it looks like just regular markup, and you can use CSS and stuff directly. That's cool. So it looks a lot like that. However, with the code generation and the WebAssembly, obviously it's quite a bit different what's occurring under the hood. Good. So let's talk a little bit about wiring. And what's the first slide here? So yeah, exactly. What does wiring mean for a Go UI app? If you're wiring a regular server-side program, right? So you are writing a web server and you need to make a HTTP.server instance, and it needs to have a handler, and that handler is actually a router which then connects to other things, and each of those other sub-handlers have the things that they need, and it needs a database connection, and it needs a this and a client for some API, other external API service and whatever, all these different pieces to the puzzle. In that situation, you can use something like Google Wire, which is a pretty cool project for that. They've gone and said, well, we can generate Go code that will kind of stitch together your different pieces to this application. And so you don't need to worry about where you're going to get your database connection instance. Assuming there's just one of them, it will match it up by type and just pop it right in there. It's pretty cool, and I've had some success with it. I want to use it more, actually, but I really like the idea. However, in a Vugu program, it's different because, realize, server-side programs, they usually you group it by executable, and an executable has one kind of like basic function. And if you have to do a completely different type of thing, usually you put that in a different main function, and it becomes a different executable. And you can kind of do your wiring based on, each main function kind of has the wiring that's associated with it. But in a Vugu program, it's not like that. You can click one button and the entire screen can completely shift, and you're on a different screen that has completely different data. That data needs to all get loaded, and there can be delays involved and all this stuff. So a big difference with these user interface apps and what we're doing in Vugu is you don't have this assumption that one executable does kind of one main thing and it just gets wired at startup. It's not the case. You can create things all the time, add and remove things, and each time you create something new, you need to then perform the wiring on it. So in JavaScript, if we look at the wiring, and Vue is probably the main thing that I'm using for a reference on this. However, there's a lot of similarity in a lot of overlap in what Angular does and what React does. So that's fine. We don't need to go too much into that. But the wiring that you see in a lot of these JavaScript frameworks tends to be pretty magical, right? If you look through Vue code, you're going to see things that says, this dot dollar store dot whatever, right? And or maybe even some import a package or module in JavaScript, same idea. And then you see a package level reference there. And the problem with that is if you have this dot dollar store, where did that come from? Literally, where does what's its type? What does it have? What other things does it have on it? Where's the documentation? All that stuff. And that's a fundamental thing that if you look at Go programs, if you write your Go code so that you have a method on a struct, and that method on the struct, everything it references is also a member of that struct. Then all of a sudden, your struct declaration becomes both documentation and also proof. If you're always using that, you know exactly what that struct needs in order to function. So that's an important point, and that doesn't really, I don't see a lot of people doing that in JavaScript. You see a lot of this dot, and then you're like, what is that? And you get to go and search for it and dig through the documentations and see if you can figure out where that's coming from. And I think that's a big time waster. It's the thing that I don't like about writing in JavaScript code, and I think we can do better in Vugu programs in Go here. And that's is a lot coming from the language itself. That's not necessarily a Vugu idea. That's really just writing good Go code.
a break, what we're going to do is go live with Brad just for a quick minute to say hello to you all before starting with the second half, so that we have a few minutes for Q&A. So really quickly, let's bring Brad live to say hi to you all.
Can you see me? Can you hear me?
Thinking.
Okay.
Oh,
Okay.
wonderful. Hi, Brad.
Hello.
It's great to
All
have you
right.
here at GoLab.
Thank you very much. It's great to speak. It's it's a good opportunity, and I hope that was somewhat informative. I know it's kind of dense, covered a lot of material in there, but I hope it's helpful.
Excellent. Yes. And I see we've got some questions coming through. We'll definitely answer them after the second part. So if you have anything else to say beforehand, before we go to the second part.
I mean, not too much. All the information is there's I don't think there's no links or anything in the slides particularly, but it's vugu.org is the website. So if you're looking for other information there, and the GitHub issues are a good way to get in touch with me if you're, there you go, get the link in the chat there. So anyway, if you want more information on the project, I'll definitely answer what I can here, but that's where to go for more info.
Awesome. Thank you for that. All right. So without further ado, let's go to the second half and then we'll answer all the questions at the end. Thanks.
Great. Thanks.
To mention the example shown in this slide there, or on that bottom point, if we're talking about the currently logged in user, right? Well, we can have a struct that houses that information. Maybe it has the user name, a user ID, I don't know, a login time, whatever is appropriate. We can put those pieces of information on a struct, and we can just have a pointer to that struct, and that pointer gets attached to whatever UI component. So if you're in the top bar and you need to show the username, then your top bar will have a pointer to the logged in user data struct or whatever. And as long as we can populate that pointer with the right thing, then we're good. If you have another component and it doesn't care about the logged in user, then fine. It doesn't have that pointer and it can be that much simpler. But using that simple mechanism, again, we're just doing the same thing we would do in Go. It tends to work really well. So let's walk through a more specific example here of, okay, it's a trivial example, but I want to show you the actual pieces, right? So in this case, we have a type counter, right? We've got a struct, and it has C, which is just a count, and we've got a method on it called nextCount. Okay, pretty simple. You call nextCount, it increments it by 1, gives you the new value. Nothing particularly special happening there. Now, this is the ref code. So this is a little bit of a pattern here. I plan on adding something to the code generator that will emit this for us, because really this is just boilerplate. But if you look at what's happening here, we've got a counter ref struct, which embeds a pointer to counter, right? So as long as that pointer to counter in that counter ref struct is not nil, you can treat a counter ref just like a counter, okay? Now, counter ref also implements the counter setter interface. The next line down is counter setter. It's pretty simple. It's got a counter set and it accepts a counter pointer. And the counter set method of counter ref just gives a way to, using interfaces, we can check, does this thing support counter setter? If so, great, give it a counter, right? So just those few lines, and it looks the same for any of any of the different things you need to wire, right? Again, like I said, you can actually code generate all of that. All you need is the word counter, and everything else is exactly the same. So that gives us a way to say the purpose of this. Let's see, what did I do here? Yeah, the purpose of this is that now on your component, right, we've got our demo comp 1, and it has a counter ref on it. It embeds it. So you can do on demo comp 1, you can do c.nextCount. You can call this nextCount method because it's all embedded right on there. And our component here, our demo comp1, implements the counter setter interface because it's embedded a counter ref. And so it's very easy to just check, does this component need a counter? It's just an interface check. And if so, great, you call set counter and now it has it. So that's a way of using the Go type system to very simply declare that a struct needs to get access to something and then be able to wire it up. So then the next thing is the actual wiring. For this is sort of our startup wiring function. This gets called directly from the WebAssembly main function. And it simply says, good, we're going to register with the build environment. That there's a build environment is just a thing that keeps track of any of the stuff that we need to know during our render pass when we're doing this conversion of from our components to our virtual DOM in memory and then the actual output to the browser DOM. So that whole loop, right? Which is driven by the main function. But in here, we're just providing a function that says, this is our wire func, and that says, good, call this function when you need to, every time a component is created. And so you can just see a little type assertion in there. It's pretty straightforward. It's like, cool, is this thing, does it implement counter setter? If so, great, give it a counter. So that code is very easy to write and allows you to just, stitch this thing together. And this is sort of our wire function that gets called dynamically to hook up the each component as it's created. That's the key point here, right? Is as each component is created, this wire function gets called. So just to recap, you got those few pieces there, but it makes the code very clear and obvious. We're using the type system for what it's good for. That in our example, our demo comp1, it is declaring what it needs as a field on the struct, right? So we don't have magical global things, right? And that allows us to go ahead and easily inject our counter or our logged in user or whatever it is. It becomes a very simple type assertion, very idiomatic for Go. And it's a bit more verbose potentially. I guess, I don't know, maybe not even be more verbose. I think I'm mainly thinking of that boilerplate, the counter setter interface and all that stuff. Like I said, if we can code generate that, which I plan on adding soon, it really is a few lines of code we're talking about for each thing that needs to get hooked up. And so you have to understand the pattern, but once you do, it's very simple and it fits the Go philosophy really well. It should be very maintainable and so forth. All right, let's talk about state management. All right, so what does this mean here, right? When we talk about state management for a Vugu program or a user interface program in general. So the fundamental thing that these kind of reactive web frameworks do is they say, when do we need to update and resynchronize the internal state of the program with what shows on the screen? That's fundamentally what these reactive user interface things do, whether we're talking about Vugu, whether we're talking about React, Angular, Vue, whatever, right? It's did this component change? That's the hard part, right? One of the things that gets added into this that is, in my opinion, it definitely is a place where this can easily go off the rails, is taking every change to the state and packaging it into some sort of like action, right? You see this in the there's like this pattern that they like to use in Redux and these different things where we've gone and said we are going to take when the user clicks something, we're going to package this into some sort of object that then can be we're going to have a commit this action, and then it then modifies some state and makes a whole copy of it, and then it's a pure function, doesn't have any side effects or whatever. So it's fine. There are reasons that was chosen for it. However, it gets complicated, and I find that in looking at these different programs, a lot of times you don't necessarily need that much complexity, even in large complex applications. There oftentimes you don't need that much complexity. You're better off keeping it simpler. We'll break this down a little bit more in a moment. But the other issue is I call this is the Highlander effect is what I call this. There can be only one, this sort of singleton idea of ending up with something that you assume is there's only one of, and then you end up with multiple of it later when you actually go and put the code through its paces and start to develop on it more. So let's break this down a little bit. So to cover this idea of did this component change, if we look at what other, what Vue does, for example, other frameworks and libraries, Vue has a concept of data binding. Now, data binding essentially says when we assign to a property, in this case, I give the example there of store.myprop equals whatever string. When that assignment occurs, it has hooked into using the setter feature of the JavaScript language. It's gone and hooked into that, and it's able to propagate that change to anything else which depends on it, right? And the depends on it is usually this concept of like a computed function. You make a function, and if it mentions store.myprop, then that computed function will automatically get recalled when store.myprop changes. Now, it's an interesting idea, and it depends a lot on the JavaScript, the setter feature of the JavaScript language, right? So, and it can be nice when it works. There are some upsides to it. However, there are definitely pitfalls. Not every possible change can actually be expressed with this setter functionality. It's possible to mutate data in a way that will not be captured by a setter. And so you end up with these things where you say view.set, which is kind of a deep copy mechanism sort of thing that gets around the fact that your setters don't always function correctly. And so you kind of end up with this code that's like, oh, it's simple for the simple cases sort of when it works, but then you end up with weird bugs and you're like, oh, I have to go hack around the fact that this particular type of update didn't work properly. And I know in my experience writing Vue code, that's one of the places that has been a pain point, is that things sort of, you never know when your data binding is going to stop working. Now, there are, it's not that you never know, there are exact rules, but they're not simple, they're not obvious. So I think we can do a better job on this. Now, in Go, right, we don't have setters. There's no such thing as magically hook into this property, this field assignment on a struct, and perform this other thing. Now, you can create setter methods for everything, and that's fine if you want to do that. There's no problem with it. But there's nothing, the language doesn't have a mechanism for automatically doing that. And I think that's mainly a performance thing, right? JavaScript has a tendency to add this sort of like, well, we'll just add another feature and add another feature. And of these, hundreds of little features, you can kind of compose what you want. But then you end up with the other problem of having to choose which features you want to use, right? It's the same problem in C++. It's just there's so much in the language that to get something done, you end up using only a subset of it, and another developer coming into it is like, well, which subset of the language have they chosen to use? And maybe they want to use a different subset of the language, and you get this whole mess. So in my opinion, setters are kind of part of that, that sort of overcomplicatedness that you see in a language like JavaScript. So again, not to knock it, that's my observation when you compare. So Go doesn't have them anyway, so we can't use them. So there's nothing really else to discuss on that. So what we've done here is said, well, if a component changes, a component can implement the mod check function. It has a mod checker interface. If it has a method on there, a mod check method, it implements the mod checker interface, and that allows it to customize the answer to this question of do we need to re-render, right? And if you do not implement that interface, then Vugu will provide some default functionality. Will scan the fields of your struct and does some hashing and stuff to keep track of that. And it works pretty well, so you get good default behavior, but if you don't like it, you can just implement the method and you're all set. So I think that gives a good balance of being able to customize functionality when you want to, but not having to in every case. And it also keeps it so that things are just Go structs with methods, right? It doesn't add, for example, we don't do wrapper types. We could have said, to whenever you want to represent a list of things that might change, we'll provide an array list type that's like everything's a generic, interface, and you can get and set another one of these generic maps or list sort of things. You have the same problem with maps. You can make one of those, and then you have to call set to assign something, and then you can add a listener for that. We could have gone that route, but again, we're really just piling on these different things. If we can avoid that, we want to. It's because it's not good Go code to wrap things unnecessarily. You see, every time we add an abstraction, there's got to be a good enough reason. And if we can not do that sort of thing, it's better. So I think so far we have a pretty good system for that. Okay, so actions, right? This is a bit more on this idea. So of the idea of taking changes in your application and wrapping them up into objects, right? I don't want to go and put a bunch of examples in here of JavaScript code that I don't like and don't think is a good idea. I didn't include all that in the slide, only a little bit. But the thing is this: you can go and you look at these other React and Vuex and this stuff, and Redux, right, for React, and they put a lot of emphasis on every time you change something, you have let's say this is we're going to do copy. We're going to copy something. So you have a command called a copy command, and it has an object with different properties on it, and that describes this copy command. And then they have the concept of like dispatching this as an event, and it then gets processed. There's like a handler list of things that can listen for that change, and then it updates some other state information and all this stuff. And I look at this and I go, okay, fine, but really, what's the difference? Why do we need to, what's the difference between that and just calling a copy method, right? Like, and then if you want to package the data up into a struct, go for it. You can. There's like no problem with that. If you want to have them separate parameters because it's just a few things, that's fine. One of the reasons that this is encouraged in these other languages is the idea that, for example, if you need to implement undo, right, as a menu item, you've copied something and now you want to like, uncopy it, or maybe duplicate is a better example. I have a layer, we're writing Photoshop clone, right, and we've got a layer and we've duplicated it. Well, now we want to undo that duplicate. So if you have all the information necessary to process that duplicate command in some sort of structure somewhere that describes it, then you can undo it. Well, what I would say to that is that's great if you're writing a Photoshop clone and you need that functionality. However, I would argue that most applications, and again, it's up to you what your requirements are, but most applications don't need that. Most web applications, right? A lot of times you just need to say, good, I want to change some state, and so you can just go simple. Your state, if you want to have methods on there, then great, you can say, good, go do this. I've got that just in the slide there, do something, right? It's like, cool, you want to call do something and pass it 2 parameters. You want to call it, you want to do it that way, fine. You want to do it and pass it a struct that has a couple fields, great. Pick your poison. So in general, my observation is that this idea of having to break things into specific actions in every case, and that being some sort of important priority for the organization of your code, I don't think that's necessarily the case, and I think we can just very simply say, good, here's a state, here's a, we gave our logged in user example, cool, there's a structure that has that information on it, and you go and set it, and you're good. If you want to add methods to make that cleaner, great, go add methods. If you just want to set the field directly, we've already covered the change modification, that stuff will work fine, great. If you need to implement an undo command and you need to package everything into commands, then do that. But you'll find that by needing it in your code. If you start with trying to make everything into a command, you're basically just going to make more work for yourself for no real benefit. To recap on some of the things here, these are just examples of things that going through comparing a Vue program to what we have in Vugu, these are examples of things that I think we want to avoid. In the top left, we've got here, this is part of this whole making things into commands. It's got store.commit, and it passes the name of the thing as a string, and then it has a generic object with a bunch of stuff. I don't see any reason to do that. Just make an increment method and pass it what you want. Use methods, use the type system. We can totally just do that. And then below that, we've got, this is an example of these special collection classes where they've done this thing. They've wrapped, a list or a map with, this is some special thing that has all of the event listener sort of functionality. Again, could do that. Don't see a reason to. Let's avoid it. Let's just use maps and slices. And if we have problems detecting changes, you can always implement the mod check function and explicitly say, this change here indicates this is an actual change that needs to be re-rendered. So you can easily explicitly control that if you need to. In the top right, we've got our magical wiring. We've got the thing I'm pointing out there is the store that's been added to that Vue app instance. And that store then magically ends up appearing on every Vue component. I don't think that's a good idea. In Go programs, we want to see if you use something, you should have a pointer to it on the struct where the method is. And it's really that simple. If we stick to that rule, then all of a sudden our code becomes a lot simpler. And then we also have, this is another thing. We've got functions that return functions that then do all this stuff. And it's like, I don't see a reason to do that in Go. There are some patterns that I think will come into play when we start looking at a lot of this back and forth with server and stuff. But one interesting thing is that Go routines as a thing have an interesting translation in WebAssembly programs, even though WebAssembly programs are not currently multi-threaded, right? There's not multiple threads of execution in most WebAssembly programs. They're adding that. But even so, the idea of just being able to say this happens in another thread of execution, whether or not it doesn't have to be actually concurrent, but the fact that you can just push it off and say that's a separate thread of execution and let the runtime deal with deciding how to take the only one thread of execution that it actually has and figure out what to run, well, that's the runtime's problem. And it's really nice to be able to do that and say, good, we're going to write synchronous code that's going to go and grab this data from the server and come back. It actually allows us to use the Go language to get rid of the whole callback hell problem that you have in JavaScript, where everything is a function that calls another function that calls another function when this thing's done and all that. We don't have any of that mess. We can use Go routines to express the idea that something is asynchronous. So that's really cool, and it allows us to get rid of a lot of the funkiness that you see there. And then in the bottom right, that's just a little snippet from the documentation where they're giving the example of like, oh, in this case, the data binding doesn't work, so here's how you can work around that. Want to avoid data binding in general, has gone over. And then we get to the Highlander effect. There can be only one. This is a concept where a lot of times programs will or a developer writing a program will make a decision early on in the lifetime of the project that there should be one of something. And a lot of times it makes sense based on the current requirements, right? And so if we just take a specific example, let's take a logged in user, right? Well, there's only one logged in user, right? And for a certain number of applications, that's true. And a lot of times when you start building a new UI application, that's true. However, it's easy for something to then come up that requires another instance of that. Or if we're talking about a server-side program, because this is a general concept, not UI specific, this is a general software design concept. If you're talking about a program that sends emails, maybe there's one email client, it has a server that's configured to send to, and so you have one of those, right? But then later you end up with a problem of like, well, we need to send email out from different email addresses, and these need to send to different servers. Or perhaps this message needs to get the DKIM signature or DMARC or whatever, one of these newfangled digital signatures. So that has to go as a certain category of messages, and those have to be sent out through a different server. So now you don't just have one email sender, you have two, right? In that case, if you've gone and assumed throughout your code that there's only one email sender, now you have a problem. Now you have to figure out how to go and refactor and make it so that there's these now multiple email senders and figure out which one is which. Now you can do that, but I would argue that it's generally more difficult to do that later. And we'll cover that more in just a moment. We'll cover why. So a lot of times in UI, when we're talking about user interface applications, the state of the application ends up being basically a big, fancy, not totally obvious, but essentially a big set of global variables. When you see, this dollar store or whatever, right? There's really not much difference between, import store, the package or the module, store dot whatever. Yeah, it's namespaced, but it's still global. There's only one of them, right? So that's something that we're going to talk more about that in just a moment. Let's walk through an example that's hopefully more realistic. I don't know if it's more realistic or not, but here, it should illustrate places where this comes up in user interface programs, right? So let's say you work for a company, the Bottle Fridge company, and they make autonomous self-driving refrigerators, and you're working on their UI, and you load in a fridge list for all of the fridges that the currently logged in user has access to, right? Okay, so far so good, makes sense. You drop that into a fridge list, and you build out a dozen screens that are all doing things like state.fridge list, right? Okay, it kind of makes sense. It's the way things go a lot of times, right? So far so good. But then you end up with a customer that has 20,000 units. I'm not sure how they delivered those 20,000 units. Maybe they had the autonomous self-driving fridges drive themselves. However, let's say that happens, and your startup takes off, right? Now, you can't load the entire fridge list into memory anymore, into the client, right? It starts to get too big. It's too much data to load. You've got to break it up into pages, right? So, another requirement comes up where we're doing a bunch of UI work, and we often have to switch between you're being logged in as an administrative user or a developer or a QA person or whatever, and you need to switch to becoming another user. So now you don't just have the currently logged in user, you also have this idea of an impersonated user. So the assumption that there was only one logged in user, not true anymore. Now there are two. So that's another example, and it starts to get really complicated really quick, where each of these assumptions where we've gone and just quote unquote for simplicity made it global, and then one by one you just get burned by these things as you've already written all this code that assumes that can just reach out to this global variable. So changing that global variable now becomes something that touches all these different pages, all these little components. They all need to change in order to fix that problem. So that's the sort of thing that can be very frustrating, building these large UI applications, and it's a common source of developer pain. So how can we do this better? Unfortunately, I don't have an example here on this slide. However, the basic concept is fairly simple, and it ties into what we were talking about earlier of instead of using a global something, we always have an instance of whatever we need as a pointer. We point to it on the struct that we're using, and we rely on the wiring system to tell us which thing we're using, right? So in this example of our fridge list, right, what if we, instead of just said, oh, there's a global fridge list and everything accesses the global fridge list, instead of doing that, we say, good, every page that loads, it's going to just hit the API. It's going to go and do an http.get and go and grab the information that it needs. It's simple to start, and it can be a little bit slow. It is not as efficient to load the thing. You click a button and it goes to another screen, and then that screen goes and loads the list, and you click another button, and then that is the same data viewed a different way, so it goes and loads the data again. That can be slow. So there are some downsides. However, the upside is that each page is independent. And if you go and you say, okay, good, well, this page it only shows, this is a log of the most recent one, so it is only pulling the last 100 entries anyway, so this doesn't care about the size. It's limit 100, so no problem. It goes and reaches out and does that. We don't try to use some shared global state thing. It can just call to the API separately, and it makes each component independent, right? Now, then later, as we discover that this page and this page actually pull the same information, right? Let's say we have, as an example, there's just a list view of our fridges, and then we have separately a more of like a preview, a little thumbnail thing where each one is showing maybe the model, right, and a little summary and that sort of thing. Something like that. Two different screens, and really they're pulling the same information. In this case, when we spot that these two are the same information, it's at that point, then we write something that becomes our sort of abstraction over the API that keeps that, that records that information. And so now we have our kind of like currently active set of fridges that we're using, and these two components that actually need it can then talk to that one thing. So what we're doing is we're reducing the number of places where we've made the assumption ahead of time that two things are the same. We're kind of defaulting to assuming that each thing just pulls its information newly, and then we're optimizing by combining things where they need to. Another thing we can do is we can keep the interface that this sort of like combined fridge list that these two screens need. They can have a similar method signatures, right? Potentially even implementing the same interface, but if not, it doesn't need to actually be the same. To get the fridge list from the API, it doesn't have to be the same, exact same method signature as to say to get it from this shared state where it's already cached in memory. But it's a similar enough interface where when you go to take another page and you switch from using the API call to the server to pulling from the shared cache thing, that it's a simple change, right? It's just like, cool, change the method name, maybe add an additional parameter or whatever it needs, and then it goes and points over there. So that's the core idea. Default to having each thing just be separate and connect them where it's needed, instead of defaulting to have them to use shared state everywhere and then find out that that doesn't work. All right, that's pretty much what I have. So just to recap and summarize, Go is definitely a very different language from JS. There is a long list of things that Go as a language just does differently, and features in JavaScript that kind of work well, that are designed for that. I don't know if they work well is an opinion, but they're in JavaScript. Somebody put them in there for a reason. But when we look at what Go does, they just handled this, the problems are handled differently in Go. They have a different approach. So some of the concepts that have been done in these user interface frameworks in JavaScript do translate over to Vugu fairly well. The idea of reactivity and making the state declarative, this div shows VG if based on this Boolean variable, that works well as a concept. The idea that you want to edit HTML-like markup when you're doing layout, that works well as a concept, right? As opposed to writing everything in Go or JavaScript and having to do new element tags, all that sort of thing, as an actual Go code. So some of those things work well. Markup is markup. Some things don't, right? Data binding as a concept in Vue, I tried it, I played around with it, and it just, I can't see any way to actually make that work in Go that isn't very overcomplicated. So instead, we come up with a different solution for it, and as we talked about. So and some of the things that are maybe possible to do in that are being done in JavaScript that are possible to do in Go, but I just don't think it's a good idea, so I didn't include it in Vugu. So that's basically what it is. We want to use the tools that are provided in Go for what they're good for. Interfaces, the type system, Go routines to express asynchronousness, all these things are ideas that were worked out for Go as a language. They were originally created server-side, but they work really well in a user interface, and they let us solve these problems very elegantly for that language. And that's it. Thank you very much for watching. If you're interested in getting involved with a project, using it, trying it out, contributing, any of that stuff, definitely check out the project, github.com/vugu/vugu. And I'm all over the GitHub issues. You can definitely reach me there. And thanks a lot for watching.
Welcome back. We are just about to go live with Brad to answer any and all questions you may have. Let's go ahead and bring him on. Oh, it's taking a moment. Patience. Hello, Brad. Welcome.
Hello.
Thank you so much, first of all, for being here with your contribution to GoLab. We're really happy to have you here, even if it's virtually this year. Still a good thing. At least you don't have to travel, right?
Right. Makes it easier. Yeah, thank you.
For sure.
Great. Yeah, so on the questions, I mean, somebody asked, so I guess I'll just jump. Oh, go ahead.
Hold on just a moment. I'm actually going to have someone else from Deviler come in with the questions. So really quickly before we start with those, I just wanted to ask if you had anything you wanted to say about your participation in GoLab.
No, this is a great experience. I mean, for me, it was very different recording the talk and putting all this together. I don't do a lot of talks, so this is kind of a new thing for me. I actually really appreciate the opportunity. It was quite a bit of fun, and I hope it was. I've invested a lot of my own time and effort into the project, so it's really fun to talk about it and to kind of explain some of these ideas. I hope it was intelligible and helpful to other people as well. So it was a great experience.
Awesome, and we're very happy to have you here. All right, we'll have Matteo come on for the Q&A. He's going to help manage all the questions so you don't have to scroll through everything. So enjoy, and thank you so much again.
Thank you.
Thanks.
Hi, everybody. I'll be a substitute for the late part of this talk for the question time with Brad. So we have our first question. It's from Andrew Simo. And it says, I don't understand why WASM is needed for Vugu. Can you explain, Brad?
Yeah. Okay. So very good question. The thing to understand is that Vugu it's just it's a Go library. It gets compiled by the Go compiler. Normally, the Go compiler will output, a Windows executable, an exe file, or a Linux elf, or a Mac macho, whatever it's called. But those have their own binary formats. They don't run in the browser, right? WebAssembly is essentially like an exe file, like a Windows exe file, but it runs in your browser. So WebAssembly is a technology that lets us actually take a Go program and compile it, and it's running in browser. So when you do that click and it gets handled by Go code, it does not call back to the server for that. That's happening all in browser. And WebAssembly is the binary format that allows that to happen.
Okay. Wonderful. Now we have another question from I don't know the name. It's not written. So he asks, does it work with TinyGo to reduce WASM size?
Yeah, so it does work. So the thing to understand is that TinyGo has like a subset of Go. It's not all the same features, right? So so it does compile. I think I have a test suite in there, and it's like a bunch of tests, and about 80% of them function correctly with TinyGo. So the answer is like, yes, the binaries are definitely a lot smaller, and a lot of the things work, but not everything. So that's part of what needs to be done on that, is just go through and take more of these cases that need to function correctly and get them working properly in TinyGo. So, but definitely it's a lot smaller. The test that I did on this, it was like a few hundred K. I think it was 250 kilobytes or 300 kilobytes, whatever it was. I don't remember. Somewhere right in there, which is definitely a lot smaller than the binaries that the Go compiler produces.
Yeah, a lot smaller. We have another question from Manuel. He asks, so Vugu basically has dependency injection like, for example, Angular, but we write it by hand.
Okay. Yeah, so I see. Sorry, I missed these. They were in another tab. Anyway, I'm still getting used to this interface here. But yeah, so here's the thing, right? You can write it by hand, but you don't have to. I didn't include, I probably should have spoken more about that in the talk, but it will actually go through. Vugu will take your struct with your different variables that describe how this thing looks, and it will actually go through and run like a checksum on each of the fields, and then say, okay, good, the checksum for this component is this value. And then if you change something in there, if you change a string that corresponds to some text on the page, then that checksum will change and it will re-render it. So it actually has quite sophisticated logic built into it that usually does the right thing. The main place where that doesn't work, where you have to manually write your own did this change, is if you have a lot of data. If you have a big slice of structs and it's several megabytes of stuff, then the hash computation function will spend a lot of time going through it. So the short answer is that yes, you can do that, but actually for a lot of Vugu programs, especially when you're just getting started in doing things that don't have a lot of data, you actually don't need to. It will work correctly out of the box.
Okay. Another question by Manuel. So how would a shared state, for example, the refrigerator list, actually look like? A struct that is referenced by the two other components?
Yeah. I mean, in essence, that's what it is. You would have a struct that has your your list, the fridge list, whatever it is, or it'll probably be something more specific than that. But whatever it is, it's a struct that expresses this concept of this is the thing I want to share, and then the other individual components, the list view or grid view or whatever those things are, just have a pointer to it. That's how that would end up.
Manuel was asking his question was more about the writing. The previous question was more about the writing part. As you can see from the chat, he asked the question was about if we have to write it by hand.
Well, yeah, if you're gonna have your refrigerator list shared state thing, yes, you would end up writing that. Like you're gonna end up, but it doesn't have to be complicated. It might be as simple as a slice, a struct that wraps a slice. So yeah, you're gonna end up writing what that shared component is that is written by hand, but it doesn't have to be complicated. That's does that answer the question?
Let us know, Manuel, if that answers your question.
Cool. Otherwise, I was going to say definitely this type of stuff. If you, for examples, we can do a GitHub issue, like put in the more specific thing. We can take it offline, and I'll be happy to put something together.
Yeah, if you want, you can leave your contacts here and links or whatever to the attendees. Manuel is writing. The part where you show the thing with the set counter was what I was interested in, but yes, I think it get a bit better. Thanks.
Okay, great.
Another question by Lars. How is the styling done? And will there be an option to import something like component libraries also written in Vugu?
Yeah, so, okay. So right now, it's just like regular CSS. You have the same functionality that you would have on a web page. You can have a link tag that pulls in a CSS file, or you can do CSS inline. So it's fairly simplistic right now. A component library is actually something I'm actively working on right now. I've had a few different attempts to it. But yeah, there were definitely, the plan is to have some sort of material design-ish component library. And the kind of the key idea is to keep the styling as just styles, right? A lot of these component libraries and other languages have a very they try to like wrap everything with a component and then don't expose the styles to it all, right? So I don't like that. I think what we want to see for Vugu is something where the styles are just a set. It's like just a style, just like Bootstrap, like it's their documented styles. This is how they work. And then when you need functionality, there will be a set of Vugu components that handle all the cases where we need to dynamically, on this event, add and remove this class and do all this sort of stuff. So that would be the component library. So the idea is that both of those exist and will work together, and that's definitely being worked on. But for now, you can pull in Bootstrap or Bulma or Tailwind or whatever your favorite CSS library is.
Okay. Another question by Yandra. If you are serving the Vugu application as a WASM file, wouldn't it be too big for the web server?
A WASM file, so WASM files are the ones that get output by the Go compiler. I don't know. The trivial programs are like a few megabytes. I've seen Vugu programs that are as big as like 15 megabytes. But to be totally honest, I've seen JavaScript programs that are bigger than that. Like no joke. So I don't. In practice, it actually is. It works pretty well, both server and client side. I mean, there are some issues. I've had things if you try to load a really big WebAssembly binary on a phone, that can be a problem. But I've never seen any sort of size issue server side. And client side, I would say that a lot of times it's totally fine. It's just something that we want to optimize and make better.
Okay. Another question, a lot of questions for your talk.
Okay.
Would you assume Vugu to be stable enough for a production deployment?
So I think it depends.
The name of the
okay.
Dino.
Perfect. Yeah. Okay, Dino. Yeah. I mean, so it's a very good question, and it's tricky because I want to find the right sweet spot of how to answer that. Definitely the warning label on it is that there are still pieces that are experimental. I guess WebAssembly 1 is stable, but Go's support for it is still experimental, and Vugu as a library, kind of because of that and a few other things, is still experimental. So it really depends on if you deploy a Vugu program in production. The technology's there. It's gonna do what it does. The main issues that you have to watch out for are the Vugu is still pre 1.0, so there are definitely incompatible changes that can happen. I try to avoid those on the Vugu side, but it definitely can happen if there are things where it's like, cool, this really does need to change. Then there will be a minor point release, because it's pre 1.0, and that can break things. Same thing in the Go library. Actually, you can have Go. I think they did one in between 1.12 or 1.13 or somewhere in there where they changed a bunch of stuff in the JS, the syscall JS package, and that broke some things. It's all fixable, but you just have to be aware of those things. So it really depends on what your application is. That said, just so you know, like I actually have a separate project, professional paid project with money involved and stuff. And I'm kind of taking that leap now, and I'm going to start rewriting things for that project in Vugu. So it is kind of to that point, and we'll see how it goes. You just have to be aware of those things. I don't want to tell you, yes, go ahead and use it, and then you run into all these problems, and you're like, no, you said it was production ready. That's all. So.
Yes. Another question by Manuel. If you use some advanced JS components like drag and drop, can you call back on your Go function from there, or can something like that be written completely in Vugu?
I'm not sure I fully understand the question, but so if we just take, I think I can answer it though. So that if you have a drag and drop event, you have to register the event through JavaScript. Like you have to call, the browser's add event listener and then provide it a function. However, that's the only part that needs to be JavaScript. Everything else from there should be able to be done in Vugu. So, yeah, I mean, I think that, in essence, you can write something that has something as like drag and drop or one of these other, uses some of these other newfangled HTML5-ish, whatever features in the browser. Those should all work. And like I said, it's just you have to register one little event, which, I think like at drag, on mouse drag or whatever it is, drag start or whatever it is. I believe all that stuff will work. It's worth trying out. It should work. I don't see any reason why not.
Okay. Another question from Dino. He says, so you follow semantic versioning?
Yeah, so the Vugu project just it's the same as Go modules, right? So It's I think the current release is like 0.3.2. 0.2 or 0.3, I forget. But it's all pre 1.0, so there's no compatibility guarantee. But what I try to do is, it's always we're on 0 for the major, and then on the minor, I do that for kind of big breaking changes, and then the patch for just the kind of incremental new development. So yeah, I do follow semantic versioning, but be aware it's all pre 1.0, so there's not a lot of guarantees happening yet soon.
Okay, it looks like there's no more question for you. If there's anyone who want to ask you something, just use the question and answer chat. We'll leave another minute for the latecomers. And so, Brad, I want to thank you so much from the GoLab organization. There's something you want to add for us?
Cool. I just wanted to say thanks. This is really fun. I enjoyed putting together the talk and interacting with everyone. And yeah, it's really cool. And I'm obviously really excited about my project, and the idea of being able to tell other people about it and share that experience is really cool. So thank you.
Well, thank you. No more questions. So we really hope to have you again in the next years, maybe in person in Florence. And thank you again for your contribution. And goodbye.
Great. Thank you. All right. Bye now.
Bye, Brad. And for all the attendees, just keep in mind to rate this talk in the agenda page. And we'll see tomorrow for another great GoLab journey.